It is a pleasure, a sheer pleasure to introduce this today's talk speaker. But before that, let me briefly tell about the center. This is and the series of the talk. This is we organize this series of talk, sustainability series talk, on under the umbrella or aegis of KPCSD, Kiran C. Patel Center for Sustainable Development. It has been established just 2 years back, and since then, with a mandate that it will pursue the sustainability issues. And like sometimes, although we always say that interdisciplinarity should be there, but when we recruit people, when we fund the project or we hire the people, sometimes it goes against, oh, you tell me specifically what you are doing. So we thought that under this the center, the any discipline, any faculty, or any sort of thing, if there is anything related to sustainability, that will be promoted under this center. And the first thing that we started is that inviting many people for this talk. Of course, due to COVID, several people could not. But recently, this this webinar form has provided us a lot of opportunity to reach out to those rare gems which we couldn't bring them so easily. So in that series, we have been certainly got very active, and then also we reached out one of the most beautiful place where I spent 6-7 years and started as my career, the faculty career there, Tezpur Central University, which was also the #1 ranking, NIRF ranking in 2015. And so at that time, I had opportunity to work under the headship of Professor Raja Rafiqul Haq, that is Raja R. Haq, sorry, not Raja, Raza, and R. Haq. So we always used to say just Professor Haq. So in that case, our history goes back very previously because we both are JNUites. And so probably when I joined JNU, he was already there. And but his alma mater is Aligarh Muslim University, AMU, where he has graduated in chemistry. And I can tell you that he taught chemistry, worked chemistry, sleep chemistry. And he always talk about this radical and all that. But sometimes I used to feel that why, after knowing all this chemistry, I am in water, he is in air. Otherwise, by training, we both are chemistry graduate. He's recently got a Fulbright fellowship, and for a year he has spent in the US. And it is his second tenure as a head. He is very well known in meteorological field, but mainly he got focused on that because he has a lot of philosophy and intellectual, and rightly he is in working in Northeast. So I requested him to talk a little bit related with women welfare, children, and talk about that how this biomass burning, which is a major fuel source of cooking in many parts of India, because India is the country of villages. So how does it matter, and how he look at these issues? Although this may not be relevant, but his wife is also the President Award winner writer, and her books are really well taken. So probably he is going to bring some of the leap from her also. So floors to you, Professor Haq. It is my pleasure to listen to you.
Yeah, thank you, Dr. Kumar, for such a lucid introduction. And also, I should actually like to start this today's presentation with thank you. Thanks comes at the end, but I'll start with thank you, Dr. Kumar. I must thank you for two reasons. One, that that you have given a direction to this Department of Environmental Science of Tezpur University, that you extensively worked on arsenic and fluoride of this region, and department definitely had got a good focus on this, and somebody has to carry it forward from here. And second, that I would like to thank you, Dr. Kumar, for keeping Tezpur in your mind all the time. And you kept this in your mind, and that's how you got in touch with me for this talk. Thank you all very much to invite me to talk about something very close to my heart, that biomass burning. Today, in fact, the topic I thought, does biomass burning matter? As it is biomass burning, can I move these slides? I'll not be able to move these slides. Okay.
Falguni.
Uh, to introduce biomass burning, actually biomass burning, we all know that biomass burning is combustion of biomass, living or dead. And biomass burning recently, it's in the news, especially with the biomass burning of North India. But then biomass burning was always there. It's a very old uh, uh, as human civilization grew, biomass burning also grew together with it. And therefore, biomass burning is an age-old practice we do in various forms. Uh, Biomass burning, to say that there may be some are human. That's why sometimes it's human-made, sometimes it is natural. And what is important to note here, that much of this biomass burning is seen in the tropics. That is because there are two reasons actually why we see this in the tropics, because world's most biomass is there in the tropics. That is of course number one, and also the world's poor people live here. So that is the reason why probably we see most of the biomass burning in the tropics. And also it is so important that biomass burning is an important source of trace gases and particulates in the atmosphere. And it's a very important part of the this important process of biogeochemical cycling, that is nutrient cycling or whatever cycling you talk about. And by now, because biomass burning is there for some time, and right in the 70s, 80s, people have noticed that biomass burning is a driver of atmospheric change, and therefore we must characterize and understand the biomass burning emissions. And therefore, by now, much of this biomass burning emission is understood well. Can you go to the next one? Okay. To understand the characteristics of biomass burning, as you know, that all combustion ideally should give us carbon dioxide and water, but in reality, actually, combustion is never complete. And in biomass burning is also there is incomplete combustion, and we have thousands of compounds which are released in the process of combustion. And some to name is that carbon monoxide, methane, non-methane hydrocarbon, and several kinds of hydrocarbons, oxygenated ones. Then we have sulfur compound. If it is there, sulfur is there in the biomass, so sulfur is there in the emission also. And similarly, some important uh, some important species I must mention is methyl chloride and methyl bromide. They are very important drivers of atmospheric processes. Now, recent understanding is that in the particulates, biomass also releases lot of particulates in the atmosphere, and those particulates aerosol, which are carbonaceous, this black carbon and organic carbon, is again an important focus of study at the moment because of their involvement in the CCN activities. And therefore, BCEC, and in addition to carbon dioxide, there are so many kinds of uh, species there in the biomass burning smoke. Biomass, we can go to the next. So what does it imply? Uh, Biomass burning, you can see that carbon dioxide and methane are, or that hydrocarbons, many of them are greenhouse gases. So methane is of course a stronger greenhouse gas than carbon dioxide. Methane, hydrocarbons together with oxides of nitrogens are, they are precursor of ozone and photochemical smoke. That is also very important. Now we talk about that smoke formation photochemical smoke formation in North India, which is now lot of debate almost every day you see, and Delhi is shutting down, and they are blaming it on the biomass burning. The biomass burning also has some contribution in that smoke formation. And then oxides of nitrogen that form atmospheric nitrogen. We have got methyl chloride and methyl bromide. Those are very, very important species with respect to which has got interference in the stratospheric ozone. And I just told you that carbonaceous particulates, these carbonaceous particulates are, uh, black carbon and organic carbon. They interfere with the CCN activities. And today we blame it to this carbonaceous aerosol, that we have erratic rainfall or extreme rainfalls, that, rainfall and then a long span of dry days and those kind of extremes. People blame it to this carbonaceous particulates. Then we have got carbon monoxide, then we have got polycyclic aromatic hydrocarbons, and also particulates. They have health effects, and therefore emissions from biomass burning is a matter that, of global change, as it is there that, it emits greenhouse gases. It has a species that interferes of stratospheric ozone, and also it does affect human health. So therefore, it's a matter of public health, and it is also for the atmospheric chemists and physicists to study lot of interactions in the atmosphere. Can you go to the next one? So in a nutshell, as I told you, that biomass burning emission have to some extent similar attributes like that fossil fuel burning. So these all species which I named, if we burn fossil fuel, these are also there. The difference lies in the emission factor. Maybe biomass burning, it has got, greater emission factor because it's a low quality fuel. And also in biomass burning, you don't have those lesser heavy metals compared to fossil fuel burning. Otherwise, they're almost like similar. And biomass burning emissions has got, as I have just told you, that, that significant drivers of atmospheric processes. You talk about greenhouse effect and global warming, or that, interactions with atmospheric ozone formation in the troposphere and interfering with the stratospheric ozone. And what is most important is that, biomass burning emission, it contributes significantly to the regional background air quality of tropical region. Background air quality is very important because, we sometimes say that because it's a constant factor that every day people are cooking with biomass fuel in the villages, and maybe 2 meals, 3 meals, and that makes a kind of background to the regional uh, air quality. So when you talk about, go to the next. So this is one study we did about aerosol of Brahmaputra Valley region where I'm based. We have characterized the sources. We did the apportionment of sources. You'll see that, biomass burning in this region has got about 27% contribution to the ambient aerosol. And if you see that monsoon time where there is minimum and winter time when the maximum, if you subtract this winter time contribution from that by this monsoon time contribution of 20%, so that 11% would be, which are non burn, which are burned not in the kitchens. This 20% where you don't have, there is no external burning, no forest fire, no agricultural fire. So this 20% would be exclusively from kitchens, and then rest 11% maybe from other sources of burning. So if we go to the kitchens, next please. So household biomass burning is very, very important issue. Household biomass burning, as I just told you, that, in the tropics, household biomass burning, that is there since ages, and we have still going on with that burning. And there is a great exposure. We see that, in the rural areas, we use, biomass for cooking, and without knowing that, there is emission and there is exposure can do a lot of damage to our health. So that is going on, and there is great exposure to the great exposure risks to this kind of emissions. And what really matters here is that, there's a gender bias to this entire process of cooking and exposure, because it is the woman of the household who's actually engaged in cooking in a patriarchal society, like, in the Indian subcontinent and in the African region. You'll see that woman of the household is responsible for the food, and she is the one who, finds all that, what to cook and what not to cook, and that energy needed, that firewood for the household. And therefore it is the woman who suffers the most. And at times what happens, that children, they accompany the woman of the house, children accompany their mothers, and they also get exposed to this, emission. And then, and in return, what happens, that, they suffer from various kinds of, disease, ailments, because of this kind of exposure. And it happened in my own family. One of my aunts died of, COPD, and her husband died young. And my cousin, who was a young one, used to be all with his mother, so he also died of COPD. He was a non-smoker. So now I understand that, what had happened in that process, because she was the one who was busy cooking with firewood all the time without knowing that, this is affecting her. So household burning adds up to the ambient level of air pollution too, because just now I was saying that household biomass burning, it would, add up to the ambient concentration levels, in the ambient levels of PM and other gases. If you see biomass burning in the kitchen, this is an unpublished. Oh, this is an unpublished work. I'm sorry, it is not published. This is an unpublished work. And here these are this type A, B, C, D. These are different communities, and this is the clean. The blue line is the clean cooking. Clean, I must say that clean fuel is LPG, as I said, compared. If this is actually, we have plotted number density of particulates against particulate diameter. So if you see that particulate diameter, which is in the lower, less than 0.1, if you see the difference between the when you use a clean fuel and a biomass fuel. Of course, these biomass burning kitchens, these are not well ventilated, which we had done, not well ventilated. And this LPG kitchen is the one where, it's a modern house and with good ventilation, and no other source of pollutant. These households which we choose, these are of different communities. I don't want to name them here, and they all use, their cooking methods are different. But then, if you see that, those particulates of less than 0.1 micron, they're almost similar, but then higher than that is a little different. But, their pattern of emission is similar. Also, there's, LPG house is also similar, but then, this number density is much lower, to the level of 10 to the power 2. So, so there is enough exposure from biomass burning. So one gentleman, Professor Smith, he actually was the whistleblower. He was a good friend of India. He visited Tezpur, and we had a good time talking about biomass burning and kitchens. And he was involved, he was a good friend of India. He was involved with the Clean Air program of India. And he had a discussion. He said, "Oh, no, I must add you in that." But sorry thing, what happened, that he succumbed to stroke this year. So a good friend of it, he is the one who, he kind of raised alarm that, that biomass burning, indoor biomass burning can do a lot of damage to our health. And these are all listed from all different kind of meta-analysis. He has listed these, some of those important ailments that is, that comes from biomass burning. One that I just told you, the COPD is very common in women, those who are involved in cooking. And then acute respiratory infection, lung cancer, cataract, tuberculosis, adverse pregnancies, and cardiovascular disease, to name some. And there are many uh, other ailments which have already been identified, and which are, there are reports that they are quite common in in rural areas of South Asia. We go to the next. So does biomass burning matter? I must say that yes, biomass burning does matter, and we must engage with this problem. And to do so, it is important to have a classification of biomass burning to prioritize action. And this is what my thought comes from here, that how we should actually engage, because we have to prioritize. We have to have a classification of biomass burning. People say that there is forest burning, there is burning in the kitchen, there is burning in the agricultural fields and blah blah. So but then we have to see the need-based classification, because biomass burning is associated with human life, and therefore we have to classify it with our needs, and that is how that would in fact give us better sense to regulate and kind of prioritize our action. So so this is one classification. This is I just told you that the speaker's own classification, unpublished, not reviewed. So I would enjoy if I get questions on this. So I had classified it like this, that one of them is essential burning. Essential burning is the one which you see that burning in the kitchens. I named it as essential burning because this is associated with the food, because that's why I'm saying it is essential burning. And this essential burning started ever since human being discovered fire. So this is one essential burning. That's why I named it as essential burning. The other burning, you see in the agricultural burning or some forest burning for management. So agricultural burning, now it is a limelight. You see that agricultural burning, people are talking about it, and it is good that government is taking cognizance and thinking about making policy. But then policy should serve people's interest. So that is one very important thing. And now agricultural scientists have also developed something for this kind of agricultural, to minimize agricultural burning. So that is one, management burning. Management burning is in the agricultural field, because that is to manage. And also in the forest, there is a kind of management burning in the forest also, to manage the grasslands, to manage the tree species and blah blah, those things. We do management burning there. There's other kind of burning. I named it as festive burning. The festive burning is, in festivities we burn biomass. So that is also one thing that is you cannot kind of people go ahead with burning huge volumes of biomass, and there are many examples. Maybe some of them I'll be talking about them. And there's some natural burning, natural fire because of lightning induced or some other kind of burning. So let's go ahead. So I'll be talking about this essential burning. This is one we have to think in the economic terms, because essential burning is one which is associated with food. I have categorized into two types of essential burning here. One is that forced biomass burning, other is unforced biomass burning. This forced biomass burning I'm saying because this division I have made on the basis of population having land holding and those are not having land holding. So people who are unforced, they have a lot of biomass stock with them from agriculture because they have land holding. Forced biomass burning, they don't have any other option. So now the question is that our government is doing a very serious, sincere effort to reach clean biomass, clean fuel, LPG to all households, and that is absolutely a good thing. Taking health into consideration, that's a great thing that the government is doing. And I have to share with you, because I was monitoring those emissions from biomass houses. So those houses who participated 4 years back, half of them has already converted to LPG now. So the rate is very fast. They are really converting to LPG. So that is very good. But what I'm saying here is that there is one class of people, they are landless people, and for them, if you want to really give alternate fuel, I'm saying alternate fuel. I mean that that support should go immediately to them first, then the people who are having having land holding and have got kind of good biomass stock from their farms, then to do that. Actually, what happens? Those are having those biomass stock with them. They will not immediately go. You give them LPG, but they will keep it only for preparing tea and nothing. They will burn that biomass anyway. That is one. And if you force them that you use this LPG, they will not bring that biomass from the field. They will burn it in the field itself. So that's just why I'm saying that there's one unforced one and the forced one. And if you really are serious, then you give quick LPG connection to those forced biomass burning population. So also what is important here is that biomass can ensure decentralized energy efficiency to our villages. Uh, so as it is, decentralization and self-sufficiency of resources is very, very vital for a sustainable society. And biomass burning can give, decentralized kind of fuel to the the village folks, and therefore, while you're talking about it, there has to be a lot of intelligent move in this regard, of whether to switch to some other energy sources. And also biomass has all that potential to be renewable, and therefore herein why not we develop more technology to use biomass. And if we go to the next slide, uh, this one, this is another study we did actually with all different kind of biomass burning. Here in this, I don't want to say anything about this concentration, but what I want to tell you that, you can see that, the composition is different when you talk about different biomasses, composition is different. What does it mean? It does mean that, emissions from biomass burning can be manipulated. And I have cited two studies, one from India, Chengapa et al., and one from, I think this was from Mexico. Herein, they have used improved cook stoves, and with improved cook stove, they have reduced carbon monoxide up to 70%, and particulate matter of PM 2.5 up to 44%. And this study here, the other one, Smith et al., study from Mexico, they have reduced carbon monoxide up to 70% and PM up to 65%. What I want to say from here is that, that emission of biomass burning with can be regulated and can be manipulated, and we can lower that emission if we use technology. In fact, in India, we had improved cook stove permission that lasted till 2003, and I don't know what was the reason to discontinue that. But then if you go to the villages now, you will not see any improved cook stoves. I don't know why it is not there in use. Can you go to the next? So other one is, I'm almost there. I don't know how many minutes I have. I'm almost there to the end. So other burning is management burning. This management burning is, we clear agriculture field, and we make field ready for the next crop, and or that sometime we, for the management of grassland, the forest people, they burn, and that is also a management burning. but but here what is important, we can see that all that biomass burning in the fields of Punjab and Haryana and Uttar Pradesh and all those places, what is there is that they are readying for the next crop, and that's why they are burning. But what is important here to look at that there is a kind of change in the agricultural pattern itself. I mean that if you see that rice cultivation, rice should be grown in wetter places than a dry place. So they are not historically, they are not growing rice, and they have the in between some crops, they have a window wherein they are growing rice, and they want to hurriedly clear it and they're burning it. But then what good thing is that already uh, already some formulation have been developed by um, by agricultural scientists, and that formulation helps to kind of converting those rice stubble to manure. Also, that if you talk about it, why not, I if you ask me what you would suggest, I would suggest that if you have agricultural waste, you harvest it. I would just say you harvest it, all that waste, it should be harvested. And we should empower the farmers to upscale those agricultural waste. Or maybe today we are talking about fuel and biochar. Biochar is one that why not we convert the biochar them into biochar, and spray in the field, throw in the field again. Similarly, the grassland management by the forest people, why not harvest that grassland? We have a Kaziranga here, we have tall grasses there, they burn every year. I think that time is coming during February, they burn. And why not, you if you really want, they burn it, of course they have something to say that they want to manage the grass, and that leaves a kind of nutrients up. When you burn that, you immediately get some nutrient in terms of but then if you really are serious about nutrient, why don't you harvest it and make some manure or make some biochar and reintroduce into the forest. So that is one. Can you go to the next? So there's another one, is this festive burning. The festive burning is one that it also has incremental effect on air quality. Like for example, that Meiji burning in Assam, or that Holika burning in India's mainland, and there are other kind of biomass burning in the state of Kerala also. They have all those biomass burning practices. But biomass burning, this kind of practices, you see that there is competition between villages, competition between households. That I make a bigger biomass lot and I burn and like that. But then with understanding of this effects of air pollution, ambient air quality, with the with the understanding of the effects in the atmospheric processes. Now I can see, especially in Assam, that they are in the urban areas. They have started making symbolic celebrations, wherein they make hollow mejis. And and I'm sure for these kind of burning, what would be interesting to work would be you engage with the community, then you talk to them, talk to their effects, and blah blah blah, like that. So when you make some policies and you involve those people, that would, I think, make better sense in this kind of a burning. The last kind of burning is that natural burning. This natural burning is actually that large biomass burning in forests, which you see, the what recently had that California fire, or that we had that fire in Uttaranchal, and natural burning. Herein, you can see that impacting regional or to global scale, large scale. And herein you need to have satellite monitoring and to help locate those fire. Nowadays, you can actually locate fire from the satellite imageries and all that. And how to put it off, I really don't know how to do that. But then I'm sure there has to be international collaboration in that, international involvement in that, to work in this matter. But to conclude, I must say that biomass burning does matter, and our engagement must be very intelligent engagement with this issue, and which is imminent. Uh, with this, I would like to conclude with a very short note.